Okay, so transportation problem is kind of the introductory optimization problem for supply chain modeling. Basically, it's a linear programming problem, so all the decision variables are going to be continuous, where your decision variables are how much product to ship from a set of origins, from each origin out of a set of origins, to each destination out of a set of destinations. Each destination has a required amount of product, or demand, essentially, and each origin has a maximum amount of product it can ship, which is its capacity. So when you have a required amount that each demand point must receive and a limited amount that each origin point can ship, you're not necessarily going to just ship it from the cheapest or closest location, because that might not be possible given the capacity constraints, and you'll see that in the example. In the transportation problem, the objective function is calculated by multiplying the total volume from each origin to each destination, each of those pairs, by the distance between them. And then you want to minimize the objective function because you don't want to ship farther than necessary within the capacity constraints. This is very, very close, at least in spirit, to most supply chain network design problems. And that generally, the farther away you're shipping something, the more expensive it is. And so you generally want to ship from a closer location. Of course, there's a lot of exceptions to that, but that's the general rule in practice.